All right, guys, welcome to our FRQ notes for, I believe we're on week 11 now. This is on page 80 of your FRQ notebook. This is question 6 on the 2015 Calculus AB FRQs. So, consider the curve given by this equation. So they give us an implicit function here, and they actually give us the derivative of that function as well. So part A is asking us to write an equation for the line tangent to the curve at -1, 1. If you ever want to find a tangent line, you need three things. You need an x, you need a y, and you need a slope. And once you know those three things, you can plug it into the tangent line formula that we've used so many times this year already. All right, here we go. So these numbers here are the x's and the y's. So they give us an x and they give us a y. We just need to find the slope. The slope is what you get when you plug the points into your derivative. So let's do that. So y is 1, so that'll go here and here, and x is -1. So that's going to be 1 over 3 plus 1, which is 4, so my slope is 1/4. And we have 1/4 x minus 1. Actually, it's going to be plus 1. And the reason it's going to be plus 1 is because it's minus a -1, so it's plus 1. And then plus 1 here. And we can just stop right there. And here we could see how they'll grade you on this particular FRQ. You get 1 point for finding your slope of 1/4, and then you get 1 point for writing out your tangent line. All right, let's move on to number 2. So this one here says, find the coordinates of all points. So that means there might be more than one answer. So find the coordinates of all points on the curve at which the tangent line to the curve is vertical. All right, so that's a weird question, and they're going to throw weird ones at you sometimes. So you got to start thinking a little bit. So let's go through a mental process here. We're looking for a tangent line. So that's a line that will touch this curve at a single point, but it's a special kind of tangent line. It's going to be a vertical line. So I have no idea what this function looks like. But I'm going to sketch something, and I don't want you guys to write this on your notes because it's completely bogus. But I'm just going to draw a curve that looks something like this. I don't know. It's probably wrong, but it's definitely wrong. But anyway, it doesn't matter. The point is I drew it like that because I know that our tangent line has to be vertical. Okay? So what do we know about vertical lines? Well, we know that vertical lines, although you might have forgotten this, but vertical lines have an undefined slope. This might be a good thing to write down in your notes. Vertical lines have an undefined slope. Okay? We also know that this tells us our slope. And so now the question is, what points will make dy over dx undefined? Because if I can find the points that will make this function undefined, then that would be the place where I would have a vertical tangent line. Okay? Well, how can I get this thing to have no solution? Well, the answer is anytime the denominator equals 0. Okay? So if we take 3y squared minus x and I set that equal to 0, if my denominator equals 0, that will make the slope undefined because you're not allowed to have 0 in the denominator. Okay? Now, I want to before I go any further, I just want to stop and talk to you. I've seen 2 questions like this in the past in FRQs. If they're asking where is it undefined, that's usually, you're going to take the bottom and make it equal 0. If they ask you where will the tangent lines be horizontal, you make the numerator equal equals 0 instead, because a horizontal line has a slope of 0. Okay, so, and when the numerator is 0, the fraction equals 0. But if the denominator equals 0, then it's undefined. So if they're asking for horizontal, you set the numerator equals 0. If they're asking for vertical, you set the denominator equals 0. So a lot of stuff there, but there it is. So now we don't need to really, these are good notes to have here, but they're really not part of the solution, okay? So now I'm just going to go ahead and start writing down the stuff that has to do with the solution. So I want to find all the points on the curve where the line is tangent to the curve and that tangent line is vertical. So I know now that means that the denominator of my slope or my derivative would have to equal 0, which would mean that x equals 3y squared. I just add the x to the other side. Now what do I do? Well, I want to solve for x and y. Well, I've got an equation here that has an x and a y, and I've got another equation up here with an x and a y. That's what we call a system of equations. So I'm going to take this function here, and you'll notice that I got rid of the x, because in its place, I'm going to replace x with 3y squared in this equation here. Now, you guys might feel like your head's spinning right now, but bear with me. Your example will be pretty similar to this. Here we go. We're going to multiply these together. We've got 3y cubed. Now, what's 1y cubed minus 3y cubed? That's negative 2y cubed. Now what? Let's solve for y. I want to divide both sides by negative 2. Y cubed equals negative 1. How do I get the y by itself? I'm going to cube root both sides. And the cube root of y cubed is y. And the cube root of negative 1 is negative 1. And there's my answer. All right. Now, I'm not completely done because the problem's asked me to find all the points. Okay, this is not a point. This is a part of a point. A point has an x value and a y value. So now I need to find the x value that goes with it. So I'm going to take this equation again. 3y squared equals x, and I'm going to plug my number in. So if I do that, negative 1 squared is 1 times 3 is 3. So x equals 3, y equals negative 1, and so my final answer there is going to be an x value of 3 and a y value of negative 1. So let's review our steps, because this is kind of a tough one, and it's not something we've seen before in class. So, but you have to get used to this. This kind of stuff I want you guys to experience on occasion, because you will get questions like this on your real AP exam. And so I try to expose you to as many different kinds of questions as possible. All this is math that technically you should know how to do, but putting it together is the tricky part. So let's go through it again. What was the first thing I did? The first thing I did was I noticed that they wanted me to find the points where we have a vertical tangent line. And we decided, okay, well, that means the denominator has to equal 0, which gave me this. And then from there, I did a system of equations. I took this and plugged it into here to solve for y. And once I got y, I could solve for x by plugging it into this equation here. Now, you could have used this one too to solve for x, but this one's easier. But either way, I ended up with an x value and a y value, and there it is. So that's the process that you would go through to find a point where the derivative would have a denominator that's equal to 0. And we could prove that right now. If you plugged in negative 1 for y, and you plugged in 3 for x, if you plugged in these points, you're going to get 3 minus 3, which is 0 in the denominator, which makes the slope undefined, which means the tangent line would be vertical. So 3 steps. Set the denominator equals 0, get the x by itself, solve the system, got your answer. Okay? Let's go ahead and take a look at how they grade that one. So this would be a 3-point question. You get 1 point for recognizing that you need to set the denominator equal to 0. And then after that, you get 1 point for doing the system of equations. It says here equation in one variable. that means that you replace the x with a 3y squared, so now you have an equation with just one variable in it, a y. And so they mean basically just doing the substitution method for solving the system there. That's 1 point, doing that proper strategy, and then finally getting the correct answer in the end. So 3 points, setting the denominator equals 0, going through the process of using substitution to solve the system, and then finally getting the answer. Let's move on to the next one. All right, so for part C, it looks like they want us to find the second derivative, and then they want us to find the value of the second derivative at the point where x equals -1 and where y equals +1. All right? So how do you find a second derivative? Well, you take the derivative of the first derivative. Okay? So my second derivative, written like this, is going to be the derivative of this, which is going to be a quotient rule. So we have low d high minus high d low, draw a line, and square below. Oops, I guess I could put that there. But... All right, so here we go. Low goes here. D high. What's the derivative of the top? Well, the derivative of y would be simply 1, but since it is a y term, we're going to multiply it by a y prime also. So low d high minus high d low. Let's find the derivative of the bottom. This first piece will be 6y, but since it's a y term, we put a y prime next to it. And then the derivative of x is simply 1. And then on the bottom, we square below. Okay? We are getting there. All right, the next thing that we're going to do is we're going to plug in the points, but you've got to be careful because we have a variable here called y prime that we don't know yet, so don't mix the y prime up with the y. So I'm going to go through here now, and I'm going to replace all the y's and the x's with the values that they give us. So I'll start off with the y's. First of all, we're going to be plugging in 1 for y. So I'm going to replace all the y's with 1. Next, I'm going to go through and I'm going to replace all the x's with a positive 1. I'm sorry, negative 1, my bad. There's that. Now, I can't go any further until I find my y prime. So how the heck am I going to do that? Oh, and by the way, it looks like I left a y out over here. There's a y. Plug that in. Y is 1. So there's that. Well, before I go any further, I think I'm going to go ahead and simplify this just because it's starting to look a little bit overwhelming to me. All right. So we have 1 squared times 3 is 3. Plus 1 is 4, so we have 4 times y prime minus, and then here we have 6y prime minus 1 times 1, and distributing the 1 in here is not going to change anything, so it's just going to be 6y prime minus 1. Now, notice that I left parentheses on here because really, if you want to get rid of the parentheses, you can just distribute here if you wanted to, but I'm going to leave them on there for now. On the bottom, we have 1 squared is 1 times 3 is 3, plus 1 is 4, squared is 16. So my denominator there is 16. Now, you'll notice that I can't really go any farther right now because I need to figure out what y prime is. Well, it's important you guys understand notation because y prime is just another way of saying this. So really, this is y prime. So if I want to figure out what y prime is now, all I need to do is plug these numbers into the first derivative. I'm going to replace the y with 1 and the x with negative 1. And I end up getting 1 over 1 squared is 1 times 3 is 3 plus 1 is 4. So y prime is 1/4. So now I can come up here and I can replace the y primes with what I just got. Now this is an FRQ. And so honestly, I would just stop here. I would not go any further. Okay? This is a great answer. There's no reason to go further and risk getting it wrong. Okay? So I would stop. Stop while you're ahead. You don't need to simplify it. All right? Let's go ahead and take a look at how they would have graded this. So it looks like they would have given 2 points for doing the quotient rule. So maybe they would give half credit if you got it somewhat right, but maybe just got like a little bit wrong. I'm not sure. But they would have given 2 points for doing your quotient rule. And notice that they're using dy over dx instead of y prime. I used y prime, but it's the same symbol, so it doesn't matter. After that, substitution for dy dx. So in other words, did you figure out that you need to plug in 1/4? You know how I went back and found out what y prime was? Did you do that? That's worth a point. And then finally you get your answer, but the ironic thing is that they could have stopped right here. They didn't need to go any further. You don't have to get to the 1/32. This is an acceptable answer, even though it's ugly. But that's it. So that's a 4-point question there. And just so you guys know, on an FRQ, they're always worth 9 points. This is 2, this is 3, and this is 4, altogether 9. And a passing score for this part, for any FRQ, would probably be about 5 points is ideal, maybe 4, but 5 is definitely typically going to end up being a pass. So that's the end of it. So hopefully that was helpful, and good luck with your practice.